Hello everyone, my name is Katie Greenslade, and today I will be going over my ECE 5000 final design, which is the Building Occupancy Counter. So this is my final design here on the right. It is in the smallest enclosed 3D printed box. On the front here, you can see there are two IR sensors. These are the sharp IR sensors with a range approximately 80 centimeters, which will cover a standard door frame. And then on this side, there is a local LCD screen. This will just locally display the count. And then under that, I have three buttons, which are manual controls, manual increase, manual decrease, and a reset button. And then on the left here, this is the node red gauge. This will be displayed both locally and remotely, and it will display the people count as well. So what are some uses of this product, you might be wondering? Well, the first use, it can replace employee sign-in/sign-out sheets. The people counter is way more accurate than sign-in, sign-out sheets, as you do not have to depend on the employee remembering to sign in and out, and you can truly always have the information on how many people are in the office. This can be useful, say an employee goes in to work on the weekend and there's not many people around. They could have a medical emergency while in the office, and you as a supervisor decide to check on your phone, say, is anyone in the office? Because you know they shouldn't be, and you see the count is 1. Well, then you're going to investigate that, and this can prevent emergencies even, this product. It is very important in large offices to know the occupancy count at all times, which this product will provide an accurate count of building occupancy. Another use of this product could be for pandemic building capacity. During COVID-19, government mandated all buildings have a maximum capacity depending on the building and the space. So all buildings had to have an extra employee with a clicker or on their phone just counting how many people are in the building at all times. The bidirectional occupancy counter can simply replace the clicker, which reduces human error. Say the person who is using the clicker gets distracted by a customer wanting them for something, and then like 5 people enter, and now your count is way off, and you could get in trouble as a company by having over the maximum capacity in a pandemic. So this is very, very useful in this case. Another use of this product could be in dangerous work sites. Some work sites I could think of are in a coal mine. You always need to know, is someone in the mine? They also use sign-in, sign-out sheets, but you can also use the building occupancy counter. This can be placed at the entrance of the mine, and it will count how many people are in the mine, and if everyone is gone by the end of the day, the count should be at 0. If it is not, you know there's an employee still in there and you need to investigate. Another place this could be used is a terminal station site. So this could be easily used on a terminal station because they have fences around the terminal station, so there's usually one enclosed entrance via gate, but you usually have to enter a building from my experience, and this can be placed at the building doorway, and you can keep track of how many employees are on the site at all times, and you don't need to go in there and investigate. You can simply check on your phone if everyone is home at the end of the day, and if not, you should follow up with that and you can potentially save lives. Because these are both very dangerous work sites. High voltage electricity and coal mines are very dangerous, so it's very important to know that all your employees have arrived home safely at the end of each day. So some features of my building occupancy counter. The count can be displayed locally and remotely via Node-RED. This allows the count to be displayed on a local network, and it can also be displayed remotely, which is also very useful. Like I said, you can check the count on your phone at your house at any time. It's also displayed on the LCD screen here on the side. This can be used just to check quickly if you're standing by the product, or it's very helpful in making sure the product is working correctly. All the counts should match at all times. And it is also good for the manual controls. You can simply see that it's increasing or decreasing or resetting if you have to use the manual controls. So it's very important to have the local display here too. Another feature, like I said earlier, the product uses 2 infrared sharp sensors. So again, the range should cover the standard door frame. Also accounting for the width of an average person, you should have some wiggle room there too. That goes beyond the door range for air possibly. There will be very minimal air. And yes, like I said, there's a local LCD screen and manual controls. Manual controls can be used in case of a sensor issue. Maybe a sensor issue comes up and you need to temporarily use the manual controls. This is still easier than a sign in and sign out sheet. You just have to click the buttons when you're entering the building for a short period of time. If the sensors were to shut down, we do have a backup, but hopefully that wouldn't be the case. I don't think it would be the case, but it's always good to have a backup. Another feature is the remote and local display. So this is the Node-RED display, and as you can see, it is a simple to interpret display design. The maximum capacity can be set to anything just based off the customer's needs, say the pandemic building mandate capacities. Each building has a different capacity, so you could set it based off that, like 25, 50 people. You can access this count both locally and remotely, like I mentioned earlier, which is very useful. And again, I have a local LCD display in case, again, any issues or you need to use the manual controls. And it's also nice just to have a display on the product at all times. So now I'm going to demonstrate the product to you. First, I will just show the product and I'll show some of the wiring, and then I'll test the manual controls. And then next, I will show the local LCD count and the sensors by walking by the sensors, and I will also test the range. And then I will show the Node-RED local and remote configuration and how that is updating. And I will also, again, walk by the sensors and test the range with Node-RED local and remote.
Hello, this is my ECE 5000 design demonstration. My project was the Arduino in-house /lab people counter using Node-RED for remote and local display. This is my final product in an enclosed box. On this side are my 2 IR sensors. Based off what direction the person's moving, the IR sensors will pick up whether they're leaving or entering a building. And then on this side, I have an LCD screen that locally displays the people count, which is good for testing. And then I have 3 buttons. This one is a manual increase, this is a manual decrease, and this is a reset button. So now I'll show the wiring. This is clearly the smallest enclosed box. Over here is my soldering board. So I did soldering for this project, and under all these wires is my Arduino, and also the buttons are under all these wires. So yeah, that's my project, and then it closes. Okay, now I will demonstrate the product by me walking through a door frame. As you can see, this is a standard door frame, And I'm gonna try and show the door frame and the count at the same time. Hopefully you can see both. The two white poles. Set this up right. Okay. I'm walking through. Hopefully the count is changing. I forget which direction is which right now, but assuming that's the increasing direction. And if I go under again, we're at 2. Great. And I'm trying to not trigger the sensor so I can see. So it keeps increasing and then walk by again. Hopefully it's decreasing. I can't see it right now. I'll walk by again. 3, and now I'll go like to the edge of the door frame to show the range. So hopefully it's picking me up. Okay. Now I will be going over my Node-RED local and remote display part of my project. Here on my laptop is my Node-RED local display, and on my iPad is my Node-RED remote display, which is also connected to my personal hotspot, which is a different network than the local display. So here is my Node-RED configuration. It's reading a serial input from port 3, which is sending to the local gauge and serving remote access. The easiest way to test Node-RED right now by showing would be to use the buttons on my product. So the LCD screen's on one, so we'll just press the buttons and we can see how the count updates and decreases. So the local display is updated to 4 and the remote display is updated to 4 after I increase the count to 4. So that worked as expected. Now I will decrease the count to 2. So local displays at 2 and remote displays at 2. And so is the LCD screen. Now I will reset the count to hold the reset button. So remote display is also at 0, local is at 0, and the count is at 0. And this also obviously works as I walk past the product. It's just harder to show everything right now, but I'll wave my hand through and we can see the count update. So now it's at 1, I'll put it to 2. I'm just waving my hand through. Remote is also updating. Now I'm going to show that my Node-RED remote and local display update as expected. Hopefully you can see both screens. So I'm just going to walk by for this part so you can see me, but it should just be increasing and decreasing as I walk based off the direction. And that should work as expected since I started at count 5. And I'll just quickly show the entire range of the door frame. I was kind of at the range, but I'll just go further up. So it should be doing the same as before, increasing and decreasing.
Okay, and that concludes my product demonstration. I can conclude that all tests performed as expected. And if you have any comments/questions of the building occupancy counter, or maybe you want to see my Arduino code, please feel free to email me attached right here. It will also be attached in the description. And thank you for watching. Bye.